This is Unit 5, Preview Video 5.5, Right Triangle Application. Sit tall. Ready? Inhale. Hold. Exhale, 5. Ready? Inhale. Hold. Exhale, 5. Don't forget date, time, and location here. Parent or guardian sign off. We're going to be doing a recap of the 5 tools here. 5 tools because you need to be competent with all 5. How do you know which one to use? You look at what you have and what you need. And right here, we have 2 sides and we need a 3rd side. We patag. Have 2 sides, need a 3rd side, patag. We're going to do leg squared equals hypo squared. So we have one leg, other leg equals hypo squared. I am not going to solve this for you, friends. I want you to solve for this leg, and I want you to have your answer in simplified radical form if need be. All right, simplified radical form, which would look like this, something root something, and I will be checking that individually. I will be looking for accuracy. Lack of accuracy, you will get docked half a point. Pause the video and finish. Let's take a look at this one. What do we have? Oh, looky there. We have a 45, 45, 90, leg, root 2. So again, chant and trace at the same time. 45, 45, 90, leg, root 2. So this one, of course, the legs are equal. Then we take this times root 2 in the margin, 7 root 2 over 2 times root 2. Root 2 times root 2 is 2. So 7 times 2, that's 14 divided by 2. This x is 7. 45, 45, 90, leg, root 2. Then you have 30, 60, 90. So there's the 30, 60, 90. Short leg, root 3, short leg times 2. It's really important you correctly identify where the hypo is here. So short leg to long leg, root 3, short leg to hypo times by 2. This reads 3 root 3 times root 3. Of course, that's 3. Answer here would be 9. And 3 root 3 times 2, only the outies talk to each other. So this would be 6 root 3. Okay, so what if you don't have 30 or 60 or 90 or 45, but you do have a single side and an angle? That is where you are going to use SOH CAH TOA. From the 53, we have the opposite. There's the adjacent. Here's the hypo. I have an OH combo. It's going to be sine. Copy exactly that down. Please don't skip this step. Sine of theta over 1 equals opposite over hypo. Remember, this is the version we use to find sides. Okay, you got to be really careful. There's two different SOH CAH TOAs. There's one for finding side lengths, and there's one for finding angles. Opposite hypo's x. Don't be grabbing those calculators until x is by itself. Quickly get your calculator out. See if you can't get the answer before me. Didn't put it in my calculator correctly. Let's do that again. It's going to be 15 divided by sine 53. There it is. 8.78, 18.78. Check for units, no units. All right, that's SOH CAH TOA for sides. Then you have SOH CAH TOA for angles. Going for this angle here, that would make this the opposite, this the adjacent, this the hypo. We have all three: opposite, adjacent, hypo. Means you get to use all three. We're trying to find angle theta. So you could do inverse sine. In this case, opposite 42 over hypo 58. That would be one way. Inverse cosine, adjacent, which would be 40 over 58. Give you angle theta. Or inverse tan. Opposite 42 over adjacent 40. Any one of those three will get you that answer. You choose one. And then I want you to find this angle and then use it to find this angle. I'm not going to give you the answer here. You find it yourself. Pause the video and do your own work. I'll be checking for accuracy. Now, all of these tools are leading up to practical application problems. Practical application problems. So this is Miss Way's not so subtle hints for success when you're dealing with practical application problems. Number one, you finger track with your finger on your paper, lips reading aloud. 3 body parts: eyeballs, finger on paper, and lips. Finger, not pencil or highlighter. 2, you filter all numbers and keywords. Filter, that means underline or highlight. 3, ask yourself, do I have an angle of elevation, horizontal up, or depression? And the last one is act the story out with gestures. You could even use models and physical objects, such as I've got a tower and a building, and you start grabbing stuff and using your hands for air and maybe extra pencils for stick people. Get used to physically acting it out because we're working in the physical world. So we're going to do 3 problems, a couple of them together and one on your own. Let's model how you do this. Ready? Put your finger on the paper and we're going to track. Finger, ready, go. Tom is standing. You're reading yourself. Hopefully you read that out loud. Go back, highlight all the numbers and what would be important keywords. You have a figure Tom 400 feet away from a tree. A clinometer is an object that measures angles. And there are electronic kilometers, but a really old-fashioned kilometer would be something where you have a protractor-like object with a string, some sort of looking through device, even like a straw. There's string with the weight on it. So as you would tilt it, it would measure angles of elevation. That's a clinometer. So you have, puts it at eye level and to the top of the tree is 38 degrees. Tom is 5 feet 4 inches tall and his eye level is 5 feet above the ground. How tall is the tree? So as you take each item, cross it out in the original problem. We're under draw, label, list, cross out. So Tom, here's Tom, 400 feet away. He uses a clinometer, so he has a device at his eye level to measure an angle of elevation. An angle of elevation is horizontal going up, horizontal going up, horizontal going up. So because it's horizontal going upward, our angle of elevation is right there. You actually have to draw in the horizontal. That's going to be 38 degrees elevation. He's holding it at eye level. His actual height is, so Tom, his actual height is 5 feet 4 inches tall, but it's very important. The device called the clinometer is actually at his eye level. And his eye level is only 5 feet off the ground because there's a difference between your actual height and your eye level height. We are trying to find the height of the tree, which would be all of this, question mark. But what you need to recognize is you're going to be working with this right triangle here, right here, and that you first need to solve for that X. All right, so there's all the details that you should have gleaned from this. Let's go to the next page and show our work there. All right, so we're going to work with that yellow highlighted triangle. Have, need, do. We have the adjacent side, which is 400, 80J. We need the opposite, which is this X. So I got an OA, and I'm looking for a side length, so that's tangent. What do? Tan of theta over 1 equals opposite over adjacent. Tan of 38 degrees over 1 equals opposite, which is our unknown, over adjacent, which is 400. Be careful. Again, don't touch the calculator. So your variable is completely by itself. Variables by itself. So we're going to do the tan of 38 times 400. tan 38, I'm going to hit enter, get the decimal, times 400, enter. Take it to the second decimal place, that's 312.5, 312.5. Hang on, am I reading this wrong? Okay, so I got 38, tan 38 times 400. Okay, it is 312. Okay. Three 12.51. So X equals 312.51. Check units, feet. But careful, 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 careful. But wait, there's more. It's like an infomercial. Okay, that 312 only goes from here to here. Okay, that's very important. You see that the 312, the 312.51 only goes from here to here. So what you need to remember is there is a 5 feet more to go to get the actual height. You add 5, total answer, 317.51 feet. Be really careful with these real life problems. When you think it's only like, boom, one step, 99.9% of the time, it is not. There's something else you have to do, either calculate a speed, add something, subtract something, work with a unit, something like that. So just be careful of there's more to this than you think there is. Ready? You are going to try this one completely on your own, and then I will do that one with you. Ready? Pause the video. Welcome back. You should have your red pen here, and you should have been correcting. Sonar vessel, unknown object, diagonal distance. You have a vessel, water, angle of depression, 27 degrees. How deep? Is it straight down? So water problem, you should have established a water line. And here is the ground. You have a research vessel of sorts. Spots a mystery object, unknown object, question mark. Says 1,000 feet diagonally. Sure that was diagonal? Yep, diagonal distance. Angle of depression is 27. You're being asked how deep. Deep is like height. It's always at a right angle. The word depth is like height. There's your X. And you can see right now we have the hypo. We need the opposite. So we're going to use sine of theta over 1 equals opposite over hypo. Sine 27 equals opposite, which is X. Hypo is 1,000. Cross multiply. So your X is going to equal sine 27 times 1,000. And you should have gotten around 453.99. If you rounded that up, no big deal, just show your work. Oh, feet, friends. I think, was it feet? No, I don't think it's feet. It is, yes, it is feet. All right, let's try an inverse SOH CAH TOA problem. It says the wheelchair ramp to the right, well, I put it above now, has 3 6-inch steps. So inch up, 3 up, up. And it's 6 inches each time. 6 inches, 6 inches, 6 inches. Keep that in mind. The length of the ramp is 4 feet. So the length itself is 4 feet. Find the angle of elevation. That's horizontal going up. So the angle of elevation would be this angle right there. That's what we're looking for. Let's kind of resketch our diagram here. Our angle of elevation is right there. We are told that the ramp itself is 4 feet long. So this is 4 feet. And this is where you kind of just need to pause for a second. We elevate 6 inches, 6 inches, 6 inches. So we come up a total of 18 inches. Have need do, trying to find the angle. We have the opposite side and we have the hypo. We need the angle. This is inverse sine. Inverse sine, opposite over hypo. Okay, you ready? Inverse sine, opposite 18, hypo 4. I'd like you to put that in your calculator right now. See what happens. Put exactly that in your calculator and see what happens. You should have gotten something like this. Second function sine, it was 18 divided by 4. And you would have gotten something like math error or syntax error. And that's because when you're dealing with sine, the numerator can never be larger than the denominator. So what you should have accounted for if you wanted to pay improving a point, watch out for units. This is 18 inches. This is 4 feet. So you need to go one of two ways. Either you take the inches into feet or the feet into inches. I don't care which way you go. I'm going to take this into inches. So we're going to go 4 times 12, 48. So in inches, it would look like this. Inverse sine, 18 inches over 48 inches. In feet, 18 inches, because there is 12 inches in a foot, 6 inches left over. That would make 18 inches to be 1.5 feet. I could do this, sine, inverse sine, 1.5 over 4, and this would be in feet, which is 1 tick mark. Both of those techniques would work, but it's important to align your units before you do any calculations. So we are going to do inverse sine, shift sine, 1.5 divided by 4, and you will see the degrees right here. Let's clear that from the previous one. Okay, shift sine 1.5 divided by 4. Should give a calculator. Shift sine parentheses 1.5 divided by 4. Forgot the parentheses. There it is. And that'd be approximately 22 degrees in that case. The other one, just so you can see that they both work, shift sine, and that was going to be 18 inches divided by 48 inches. Shift sine, again, 22 inches, which technically would make this ramp illegal because you shouldn't be more than approximately 7 degrees max, 7 to 10 degrees max for a wheelchair ramp. That's if someone's pushing. If you have to do it under your own power, it should only be about 5 degrees. So 22 degrees. Watch out for units. This problem you're going to do completely on your own. I will check for accuracy for your own preview notes. Remember to summarize what you've learned.